Hey everyone, in today's lesson we're going to be talking about terminal points. So we're actually figuring out the coordinate points for each of the spots on our unit circle. So normally I don't include warm-ups in my notes videos, but today I am because the warm-up from today's class says we need to fill in the degree and radian measures for each of the marked angles on the unit circle. All right, so if we look at this unit circle, okay, we of course start at 0 degrees. You could also think of that as 360 degrees, right? And we should know by now that once you've made a full circle, that is 2 pi radians. And where is this located? Actually, the terminal point, we can actually figure that out too. Since we know our radius has a length of 1, so we've gone to the right 1, that's my x value. And we've gone up 0, so 1, 0 are the coordinates there. We're not going to be able to fill in the whole thing for each of these yet, but we will eventually. Okay, so I like to start with the pi over 4s. They're kind of my favorites. So if you look at pi over 4, last class we learned how to convert from radians to degrees, right? So we take pi over 4, we multiply by 180 over pi, and in the end we just end up doing 180 divided by 4, and that gets us 45 degrees. All right, well, that's 1 pi over 4. All right, so 2 pi over 4, or pi over 2, is right here. And so 45 degrees, and then another 45 degrees, that's 90 degrees. So I don't even have to convert there. I'm just adding 45. All right, and then I'm at 3 pi over 4. And that's going to be 135 degrees. And then I'm at 4 pi over 4, or pi, and that is 180 degrees. I'm going to back up just real quick to pi over 2. I forgot about the terminal points there. We can come up with those as well. We've gone up 1, but we haven't gone left or right anything. So it's going to be 0, 1 for our terminal point for pi over 2. At pi, we've gone to the left 1, so it's -1, and we haven't gone up or down, so comma 0. All right, add on another 45 degrees and we're at 225 degrees, and that's 5 pi over 4. Okay, and then 6 pi over 4 reduces to 3 pi over 2. So 3 pi over 2. Its degree measure, we add on another 45 degrees, that's 270 degrees. All right, my terminal point is going to be at 0, -1. Add on another 45, and we're at 315 degrees, and that is 7 pi over 4. And we'll talk about the terminal points today. Okay, so there's our pi over 4s. Okay, so let's go on to maybe our pi over 6s, which is also our pi over 3s as well. All right, so pi over 6, how many degrees is that? Well, multiply it by 180 over pi, and you'll notice that it's just 180 divided by 60, which gets you 30 degrees. Okay, so each one of our pi over 6 angles is 30 degrees. So if I add another 30, I'm going to get to 60, 90, right? I'm just going to fill in all the degrees real quick. So 60, 90, 120, 150, 180, 210, 240, 270, 300, and 330. Okay, but of course pi over 6, we should know by now, reduces to pi over 3. Okay, and then 3 pi over 6 is pi over 2, 4 pi over 6 is 2 pi over 3, and then 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6 is 3 pi over 2, 10 pi over 6 is 5 pi over 3, and, sorry, 3, not 6, and then 11 pi over 6 will finish us off there. Okay, so that's what we have so far, and we'll end up going back to this picture in just a little bit as we go through the notes. So let's take a look here at our first scenario. So we're going to create a triangle here. All right, a right triangle. All right, so I have the unit circle drawn, and then I have a right triangle off to the right. So it's a special type of right triangle. So what we're going to do, okay, we're going to draw a radius. Okay, it's going to go halfway across this quadrant. Okay, so if we know the whole quadrant is 90 degrees, that must mean that this angle that we've created is 45 degrees. And of course, we do know that our radius, sorry about that movement there, our radius, stop moving, is 1. Okay, and we're going to refer to this side as x, okay, and this side as y. It makes sense, right? So this is my horizontal distance, and this is my vertical distance, okay? But when we take it over to this, right, if this is 45 degrees, this is a right triangle, so this is 90 degrees. I'm going to put a 90-degree marker there, 45 here. Your missing angle, right, is going to also be 45 degrees. If you don't believe me, add up 90 and 45, subtract from 180, and you'll note that, yeah, my missing angle is 45 degrees. Okay, so this is an isosceles right triangle. And some of you in geometry might have learned about your special right triangles. So I'm going to call these, since these two sides are congruent, I'm going to call them the same thing. I'm going to call them x, okay? I know we referred to this as y, but you could pick any variable you wanted here, okay? And we know that this length is 1 because that's the radius of the unit circle. So let's figure out the value of x. And to do that, we're going to use something called the Pythagorean theorem, which you should already know from your good old geometry days. All right, so we know the Pythagorean theorem, a squared plus b squared equals c squared, where a and b are, of course, your legs of your right triangle. So we've got x squared plus x squared equals 1. X squared plus x squared is 2x squared. And now we're just solving for x. So we're going to divide by 2. Get x squared equals 1/2. And then we want to square root 1/2. Well, when you square root 1/2, you can square root the top and bottom. You'll end up with 1 over the square root of 2. Now you should remember from your Algebra 2 days, you cannot leave a radical in the denominator. You have to rationalize it. So to rationalize a square root, you end up multiplying by the denominator over the denominator. So see this square root of 2 down here? So I'm going to multiply by square root of 2 over square root of 2. My numerator becomes just plain old square root of 2. The square root of 2 times the square root of 2 becomes the square root of 4, but the square root of 4 is 2. And now it's rationalized. All right, so that is what each of our legs are here. Okay, so when our angle measurement is 45 degrees, our x coordinate is going to be square root of 2 over square root of 2. And our y coordinate is also square root of 2 over the square root of 2. So our terminal point, our x comma y, is square root of 2 over square root of 2. Okay, so let's go back to that circle here real quick. And I'm actually going to just delete these so I can go back quickly. Oops, undo. I wanted to go to that one and delete. All right, so if we go back to our picture here, all right, so what we just did, okay, was we figured out the coordinates for pi over 4. We figured out the coordinates in our first quadrant. So those are square root of 2 over square root of 2. The good news is when we're in the second quadrant, well, it's still going to be square root of 2 over square root of 2. It's just literally been, the right triangle has been flipped over the y-axis. So my x-coordinate, however, because I'm going to the left first, is just going to be negative square root of 2 over square root of 2. And then my y-coordinate is going to be square root of 2 over square root of 2. In the third quadrant, remember you go to the left and you go down. So both your x and your y are negative. So it's negative root 2 over root 2, negative root 2 over root 2. And in your fourth quadrant, you go to the right and then down. So going to the right is a positive x coordinate and going down is a negative y coordinate. Okay? So now let's talk about another scenario. All right. So let's talk about when we have, oops, I think I might have skipped something. Yeah. Okay. So we're going to talk about another type of special triangle, special right triangle. All right, so I'm going to draw a line here. Okay, note that this is my pi over 3 section here. All right, which means that this angle that I've just created is 60 degrees. Okay, this side, of course, is 1. Okay, so bear with me for a moment. So if this is 1, and we can create actually an equilateral triangle with that. Okay, so 1, 1, 1. That's all those side lengths. Okay, and then we're going to cut that equilateral triangle in half. So this is 60 degrees. We know that because we specifically drew it that way. In an equilateral triangle, all angles are congruent. So this was 60, but we've cut it literally right down the middle, straight down. So that's going to make this a 30-degree angle, and this is going to be 90. Okay, so I'm going to draw that in as well. Okay, all right. So actually, I don't want to use red. I'll use black. All right, so this is going to be my X. This is going to be my Y. This is 30. This is 90. All right, now because this whole length was 1, but now we've cut it in half, that means that we do know that this side of our right triangle is 1/2. All right, and again, a 30, 60, 90 triangle is another type of special right triangle. So we can find now our missing side. So we know this is 1/2. Okay, so let's set up the Pythagorean theorem. So, and we can even call this y if we want to. So 1/2 squared plus y squared equals 1 squared, right? A squared plus b squared equals c squared. So 1/2 squared, 1/2 times 1/2 is 1/4. 1 squared is 1. We're going to subtract 1/4 from both sides. Okay, so y squared equals 3/4, right? And then we're going to square root that. But remember, we're square rooting the top and bottom. So we get y equals the square root of 3 over the square root of 4, but the square root of 4 is 2. Okay. So we have our coordinates for our terminal points. So 1/2 comma square root of 3 over 2. And this is going to work for any of our pi over 3s. So let's go back to that picture. And actually, some of these pictures, are they filled in yet? No, they're not. Every time they have it blank. That's okay. I'm going to go back into my filled picture. Okay, so now I'm going to fill in my pi over 3s with the information that we just found. So it's going to be 1/2, and then it's going to be root 3 over 2. In the second quadrant, we go to the left first and then up, so it's negative 1/2, and then root 3 over 2. In my third quadrant, both coordinates are negative. I don't know where my, oh, there it is. It moved somehow. My square root of 3 over 2 moved. And then in my fourth quadrant, my x is positive, but my y is negative. Okay. And then the last scenario we're going to talk about is, of course, our pi over 6s. Which should be right here. Okay. All right. So with the pi over 6s, okay, let's take a look here. We're going to draw out our scenario again. I think I'm running out of colors, so forgive me. Or I guess I could change my color to, I don't know, something different. Maybe this purple. That looks good. All right, so we're going to draw in our angle. So this is 30 degrees because we're talking about our pi over 6 family. So bear with me, this is going to be 60 degrees. So now it's basically like we had an equilateral triangle on its side. So now this is 1/2 since the whole side was 1. Okay, this is 1 still, my hypotenuse is still 1. And now we're solving for this missing piece. But since it's still a 30, 60, 90 triangle, we're still going to use Pythagorean theorem. We're still going to get the exact same measurement for this missing side. So it's going to be the square root of 3 over 2. So my x value this time is the square root of 3 over 2, and my y value is 1/2. So my terminal point is square root of 3 over 2, comma 1/2 for my pi over 6s. Okay. All right, so let's go back one more time to that beautiful unit circle. Okay. So my pi over 6's. So we just said it's going to be root 3 over 2, comma 1/2. So in the second quadrant, it'll be negative root 3 over 2, comma 1/2. My fourth quadrant will be negative root 3 over 2, negative 1/2. And my fourth quadrant will be root 3 over 2, negative 1/2. So you're definitely going to want to work on memorizing the unit circle. It's going to be very, very, very helpful for you. Now, excuse me, there's still a little bit more to the notes, some different ways to help you practice. So go ahead and try those practice problems, and I will make a separate short video going over those.